So now we'll discuss about graphs and their slopes. So this is the plot of tan theta versus theta. This is 0 degree, this is 90 degree, and this is 180 degree. So for the time being we need the values of tan theta in this region only. Sorry, from this 0, 90, 180, this region. So you see, from when theta moves from 0 to 90 degree, tan theta increases. So when theta moves from 0 to 90 degree, then tan theta increases, and when theta moves from 90 degree to 180 degree, then also tan theta increases. In 0 to 90 degree case, tan theta value ranges from 0 to infinity. So from here the values are, it increases from 0, the tan theta value 0 to infinity, and here it increases from minus infinity to 0. So we need to keep that in mind. Now I will discuss a few graphs. This graph, this graph, this, this, this one, this one, this one, and this one. We'll see the trends of the slope. We'll take 2 points in each and draw the tangents. Theta dash, this is theta. So you see here this theta is increasing, theta dash greater than theta, and these two thetas are in 0 to 90 degrees. So as this theta is increasing, so tan theta would increase. So let me tell tan theta as m, or slope. So m is increasing in this curve. Note that in this case see that theta dash is less than theta. So tan theta, as theta is decreasing, so tan theta is also decreasing. So slope is also decreasing. In this case, the thetas are same, as this is a straight line. So m is constant. M is constant. In this case also, m is constant, but as theta is greater than 90 degree in this position, so it is negative. So m is negative, and also we can infer here m was positive, increasing but positive, here also positive, here constant, positive. In this case theta equal to 0. So tan theta equal to 0 or slope equal to 0. In this case, theta equal to 90 degree. So tan 90 is infinity, tending to infinity or undefined. So m is also tending to infinity, or and let's take these two cases. So here both the thetas are ranging from 90 to 180 degree, and theta dash is less than theta. So in here you see that theta is, if you go from 90 degree to 180 degree, then theta increases. So here m is decreasing. You are going from 180 degree towards 90 degree, 180 degree towards 90 degree. So theta is so tan theta is decreasing. You see here tan theta is decreasing, and it is negative. Here you see that this theta dash is greater than theta. So the angle is increasing, so tan theta is also increasing, or slope is increasing, and it is negative. Okay, so keep these points in mind in the next slide. So now we'll talk about this graphical comparison, and this topic is the most important topic to be learned for JEE Advanced. So you should listen to this carefully. So the problem statement is, you will be given a displacement time graph like this one, this graph, and from that you have to derive the velocity time graph, and from the velocity time graph you have to derive the acceleration time graph. And for this we'll leverage the procedure we have discussed earlier regarding graphs, and I have in this right hand side drawn those conclusions from the earlier lecture. So we'll use this here. And how from the displacement time you will get the velocity time graph, as velocity is the slope of the position time graph, the instantaneous velocity or the velocity, it is the slope of the position time graph. So you have to measure the slope of the position time graph at every instant, and the acceleration time graph is similarly done by measuring the slope of the velocity time graph at every instant. So for from this displacement time graph you have to measure the slope at every point, and you will get the velocity time graph. And from this velocity time graph again you have to measure the slope at every instant, and you will get the acceleration time graph. So to do this faster, and you don't need to measure the velocity, but you have to see the graph trends as I have drawn in this right side. So these things we'll use to draw this. So let us divide the graph into several sections like TA, TB, C, D, E and F, where some significant things are happening. So during the interval 0 to TA you see that the graph is like this one. So the slope is increasing. So I am also doing here, the position is 0, so I assume that the velocity is also 0. So here the velocity is increasing, slope is increasing, so velocity is increasing. Here the slope is a straight line, it resembles this one. So here what we see, the slope is constant, so this is constant. From TB to TC the graph is like this, so slope is decreasing, velocity is decreasing. From C to D you see the graph is like this, similar, so I decrease the velocity till point D. From D to E you see the graph resembles this one, so again the slope is decreasing, so I decrease the velocity. From here E we see that the graph is becoming like this, so again the slope is increasing, so velocity is increasing. And onwards of TE the graph is a straight line, so slope is 0, so velocity is also 0. You see, you can easily, looking at this diagram, you can derive this one. And similarly from this velocity time graph I will draw the acceleration time graph. So in this portion the graph resembles this one, so slope is constant, so acceleration is also constant. From this point to this point the graph is like this, so slope is 0, so I slope is 0, so the acceleration is 0, and I join these 2 points as to make it continuous. And from B to E the slope is like this, so again the slope is constant, or the graph is like this, which resembles this one, so slope is constant. But you see the slope is constant negative. You can see from the previous slide that this is negative, so the acceleration is negative. From this point to this point the graph resembles this, so slope is constant, so I make acceleration as positive constant. And here the graph resembles this, so slope is 0, so acceleration is also 0. Okay, so you have to learn this slide and the previous slide very thoroughly, so this is a very important very important concept. Please practice these graphs at your home and leisure.